Okay, so we are on section 8.6, solving radical equations and inequalities. I'm going to read through the notes and then we'll do a few examples. When you are solving equations, rational equations, you need to find the common denominator and multiply to get rid of the fractions. Note any restrictions on the domain, the values that make the denominators equal to 0. For inequalities, solve for the values like you do equations. These points are called critical points and will become test points for the original inequality. So we need to check the answers once we get them against the domain restrictions and make sure that they're not, or make sure that they are usable. Okay, so let's look at number 1. So our goal is to get rid of all the fractions. So what I'm going to do is I'm going to find the common denominator, the LCM, least common multiple, and I'm going to multiply through by that least common multiple to get rid of all the denominators, okay? So for this one, my first number, 28, is 7 times 4, which I'm going to write as 2 squared so we can see all the prime factors. The second denominator is z plus 2. The third denominator is 2 squared. So that means that my LCM, or common denominator, is going to be 7 times 2 squared times z plus 2, which is 28 times z plus 2. Okay, so I'm going to take that 28 times z plus 2 and multiply all the way through that equation. Some of it is going to reduce out when I multiply each one by that denominator, and sometimes it won't reduce out. So for example, on this first fraction, this denominator 28 is going to reduce with that 28. Okay, so all you're going to have left on that first fraction is 9 times z plus 2. So I don't have that denominator anymore. That's what I want. The second denominator, z plus 2, is going to reduce with the z plus 2. So all you will have for that middle number is 3 times 28. Don't have the denominator anymore. And then your last fraction, the 4 and the 28 are going to reduce. So I'm just going to have 3 times 7, which is 21, times z plus 2. Any questions? Okay, so now we're just going to distribute, combine the like terms, and solve it like the normal equation. So I have 9z plus 18 plus 84 equals 21z plus 42. And I want to get all my z's on one side, so I have 12z. All my constants on the other side, so that's going to be 60. And then divide by 12, so z equals 5. Okay, I need to check my answer and make sure that it's not a restriction. And the way that you get your restriction is by taking your common denominator, because that's all the denominators combined, so that's going to be representative of everything that you are using. Okay, I'm going to take the part that has the variable, so in this case it's just the z plus 2. Set that equal to 0, and z cannot equal negative 2. If z equals negative 2, then you're going to have a 0 in the denominator. Okay, so you can't, if you have an answer of z equals negative 2, you wouldn't be able to use it, is what that's saying. But this is z equals 5, so that's going to be a good answer. Okay, any questions? Okay, I want you to try one on your own, and then we're going to do a harder one together. Okay, so you guys try number 3. I'll do it up here, and then we're going to do number 2 together. Any questions? So you have a restriction of 0, but your value for a when you solve it is 3. Okay, well let's look at number 2. We're going to work this one together. Find your LCM. And let's see what everybody gets on that one. And any time I have a whole number, I always go ahead and put it over 1, just so it won't get lost in the equation, because sometimes it just kind of blends and you don't really see it, your eye doesn't pick it up. So I always like to write it as a fraction. Put it over 1. So did anybody get an LCM yet?
R squared minus 1.
R squared minus 1, right. Because that breaks down into a pair of conjugates, R minus 1 and R plus 1. Okay, so I'm going to multiply all the way through by that R minus 1, R plus 1. So my first fraction, the denominator reduces out completely. And all I have left is R squared minus 5 from that first fraction. In this middle fraction, R over 1, nothing reduces out. So I'm going to have R times, and I'm going to go ahead and make that a difference of 2 squares instead of writing the 2 binomials. So that'd be R squared minus 1. And then your last fraction, the R plus 1s are going to reduce out. So I'm left with R squared plus R plus 2 in parentheses times R minus 1. So I have to multiply some things together. Okay, I'm going to distribute the R. So I have R to the third minus R on that left side. And now I need to distribute the R squared plus R plus 2 times R minus 1. So R squared times R is R to the third. R squared times negative 1 is minus R squared. So I'm done with the first term there. R times R is plus R squared. R times negative 1 is negative R. And I'm done with that second term. 2 times R is plus 2R. 2 times negative 1 is minus 2. And we're done with that one. So now I just need to collect my like terms. On the right side, I have these R squareds that are going to add to be 0. And when I subtract the R to the third to bring it over to combine with the other one, that adds to be 0. Okay, so I just have the R squared. And I'm going to, let's see. Yeah, these two R's cancel, right? But then I have this minus 2R. So it's going to be negative 2R. Okay, and then I can combine the negative 2, add it to negative 5, so it's going to be minus 3 equals 0. Okay, so we need to factor. It's going to factor to R minus 3 and R plus 1. So when I solve, when I set each of those factors equal to 0, I get R equals 3 and R equals negative 1. Okay, but I need to think about my restrictions. Your restrictions, when I set the LCM equal to 0, R cannot equal positive 1 and R cannot equal negative 1. So I can't use this second value. Okay, I have to throw that one out. The only one that I can use is the 3. Any questions?